on our semester review. This is numbers 33 through 35. Okay, remember I talked to you about the teaks listed there. So if you want to scroll back, or scroll for me, you have it on paper. So flip back to the front. We're looking at 2A 7D. If you're unsure what that is, you can come back on the front and look. 2A 7D. That's this one here. It's I can determine the linear factors of a polynomial function of degree 3 using algebraic methods. Okay. Now, there's only going to be one factoring question on the semester exam, okay? But you should be able to factor, and this was the test that we just took, Unit 5, Part 2, and we'll be retesting. We're reteaching it today in class, a little mini lesson here, and then you're going to be retesting, if you choose, tomorrow in class, okay? But then on the semester exam, there will only be one factoring question, okay? So let's flip back over to those. Thanks. All right, I'm also going to pull up some of our completed notes because we looked at not just factoring, excuse me, not just factoring basics. We had special cases, and we had, we were factoring by grouping. We did difference of squares, sum and difference of cubes, perfect square trinomials. There were a lot of variety, but remember you had those formulas on the test. So if we take a look at these, and then of course GCF is what we would always look for first. Okay, so GCF is greatest common factor. So we're going to start with number 33 here, and I'm going to look at each of these terms. And when I say terms, I'm talking about each little expression between plus and minus signs. So this has 3 terms. Is there anything that can be divided out of all 3 of those evenly? Okay, definitely a 2. Okay, number-wise, a 2. Okay, what about variable-wise? A t. They all have a t. So I could divide 2t out of all of those. That's my GCF. So when I'm doing GCF factoring, remember that you put your GCF outside parentheses, and then you put your leftovers inside parentheses. Okay, so 2t is outside. Now, when I say leftovers, I mean, what are we left with once we do that division? So up here in the first term, 2 divided by 2 is an understood 1. Anything divided by itself is 1. T cubed divided by t would be what? T squared. Remember, when you're dividing variables, that's an understood 1 power on that t. You're subtracting the power. So t cubed divided by t is t squared. Then we have a minus. And then in this term, what's 24 divided by 2? 12. And then t squared divided by t would leave me with t. Then I have a plus sign. And then 72 divided by 2? 36. And then the t divided by t, same as the 2 divided by 2. Anything divided by itself is 1. It's gone. 36 times 1 is still just 36. So I don't have to change anything down there. So far, so good? All right. Now I've got the GCF out, and I'm left with a trinomial in there for my leftovers. We talked about trinomial factoring. We looked at a few different methods. We looked at guess and check. We looked at box method and grouping. If you use box method or grouping, you start the same way with that X, right? But if you do guess and check, you don't have to do that X. Does anybody have a preference on a method they want to use here? No? Okay. When it is an A value of 1 in my trinomial, this is what I'm talking about right here. This is an understood 1. I think guess and check is pretty straightforward because we know we're factoring to the 2 sets of binomials. The only factors of t squared are t times t. So I know the first term of each binomial will be t. Then I simply have to ask myself what multiplies to 36, a positive 36, but adds to a negative 12. If you need to make a list of the factors, that's fine. You can do that. The factors of 36 would be 36 and 1. Or what else? 18 and 2. What else? Twelve and 3, 6 and 6, I heard. 9 and 4. Okay, I think that might be it. Now, let's think about the signs. We need them to multiply to a positive, but add to a negative. So what do I know? They're both negative, right? Because a negative times the negative will give me the positive, but I need a negative plus a negative would be a negative sum, okay? So which of this list, which of these added together would give me 12? Yeah, 6 and 6. I already said they're both going to be negative. So it's negative 6 and negative 6. Now, did that 2t go anywhere? No, it's still there. Don't forget about it. So that is completely factored. I can't do anything else. That's as far as I can take it. Now, if you're looking at answer choices, is there another way that we could write this since these two are exactly the same? Yeah, I could have my 2t and then my t minus 6. Instead of writing it out twice, I could just put a squared on it. So both of those would be correct. All right, so we did GCF there and we did trinomial factoring. I just used guess and check.
We don't get rid of the...
Nope, still there. You pull out your GCF, it doesn't disappear, it's still there. Now, if we go back and look at that trinomial in red, that is actually a perfect square trinomial. So if you realize that, you could use the shortcut for a perfect square trinomial, meaning a perfect square trinomial. Remember when we checked it, we said, is the first term and the last term perfect squares? Can we take the square root of both of those? Yes. Okay, if I take the square root of both of those, I get t and 6. So if I multiply them together, that's 6t. And then is that middle term double that? 12t is double 6t, isn't it? So yeah, this fits that requirement of being a perfect square trinomial. So if you make that connection, you could realize, oh yeah, perfect square trinomial, I just do the square root of the first term and the square root of the second term, and that binomial is squared, which is what we ended up with. And then the sign always matches this first sign right here, a minus, and we put a minus. See, the square root of t squared is t, the square root of 36 is 6, and we put the minus, and then it's squared. So if you recognize that it's a perfect square trinomial, of course, you can use that. But from what I've seen, the majority of you, say that again? Yeah, the majority of you don't always recognize that or don't think to look for that, and it's fine. So I showed you how to do it just as a normal trinomial. You don't have to do anything special, right? You'll feel okay about that? Okay, let's look at 34. 34 is not a trinomial. There are 4 terms here. Is there a GCF? Is there anything that can be divided out? Here's my 4 terms. Is there anything they can all be divided by? No. So there's no GCF. So if there's no GCF and it's not a trinomial or a difference or sum of cubes or a difference of squares, what should I do? What do I do when there's 4 terms? Say that again. It's possible that it's prime, but I don't know that yet until I try something. There's a type. What type of factoring did we do when there's 4 terms? Well, this might be why the test grades this week were not great. No. Yeah, that's it. Does anybody remember what that's called? Grouping. Thank you. We're going to group. We're going to create 2 groups. Grouping. So if we have 4 terms, we're going to try grouping. So we're going to group the first 2 together and we're going to group the last 2 together. Now within each group, we're going to look for a GCF. There was no GCF amongst all 4 terms, but what if we group it into these smaller groups, these binomials? Now I'm going to look, I'm going to change the color on one of the sets of parentheses here so we can distinguish. All right, so in the blue set of parentheses, the first group, is there a GCF? Yeah, both of those can be divided by 3, and both of those can be divided by x squared. So a 3x squared, again, it's going to be this same setup over here, GCF, and then your leftovers in parentheses. If you actually need to show we're dividing by 3x squared, you can show that up here. So what is 9 divided by 3? And the x cubed divided by x squared? And we have a minus. And then 6 divided by 3? 2. And x squared divided by x squared? That's an understood 1, right? It eliminates. All right, now we're going to do the same thing in orange, their second group. Okay, the lead term is negative, so I know I want to factor out a negative, and then what can both of these be divided by? So if I divide out a negative 7, what's negative 21 divided by negative 7? Positive 3, and then the x, there's no x to eliminate anything from it, so the x is still there. And then we've got a positive 14 divided by a negative 7. Negative 2. Now, how about that? When we do grouping, and we've done it correctly, we want these leftovers to match, don't we? And they do. That's a good sign. That tells me that that is a factor. So 3x minus 2 is a factor. What else is a factor? Yeah, you put those GCFs together as a second factor. So 3x squared minus 7. Now, it's possible you do this and one or both of these binomials that you end up with could be factored further. You may end up with a difference of cubes or a difference or sum of whatever, a special case that we learned about. In this particular case, we don't. This one is linear. It's just x. This one is x squared still. So it's possible we want to double check. Can we factor it further? But we can't because this is a difference, but it's not cubes and those aren't perfect squares either. So we can't take that any further. Now on the test, some questions were worded as factor completely. And that, like, this would be your answer. and they were multiple choice. Some were worded, you were given an equation or an expression like this, and it may say, select all the factors below. And it was a multi-select, and all the factors were listed separately, and you just had to click on all the ones that were factors. Okay, and then some were multiple choice, and it just said, which of the following is a factor? And you just had to pick one that was a factor. Right? You remember that from the test? Okay. You have to be able to do all those different, we don't know how the question's going to be worded. You have to be able to do that. Now, I showed you when we first were doing these lessons, and I reminded you over and over, use Desmos. You get Desmos the entire test that we just took, and you get Desmos the entire semester exam. If you understand how to use it, it'll do a lot of the work for you. Okay, for instance, if I tried factoring by hand and I got this and I'm like, I don't know if I did it right, I'm not sure. Or if it's multiple choice and there's answers of completely factored forms, and you were at the beginning of this question when I tried to ask y'all what to do here, it was dead silent. Seemed like nobody knew what to do. If you get to a question on the test that's factoring and you're like, but it's multiple choice and there's like 4 choices of what it could be, you can work backward and just check them in your calculator if you've forgotten the actual algebraic process. Now, you would have to check all 4 answers. It might take a little bit, but you can do it that way. Okay, now it's better to actually know the process and then just check what's in the calculator. So who remembers how to do that in Desmos? What are we looking for when we check these in Desmos? Yeah, if the original equation and what we got, 11 or 12. If the original equation and what we got as factors are identical on the graph, that's what we're looking for. So I'm going to pull up Desmos and we're going to check this. That's not what Desmos. Here it is. Okay, so somebody just read to me the original problem. What was it? What was that? Uh-huh. No, I don't need f of x equals just the expression. 9x cubed. Okay. All right. So here's the graph of the given expression. Okay. This is a cubic function because the highest exponent is x cubed. Okay, now we factored it to be, what was it, 3x minus 2? And then what was the other factor? 3x squared, right? Minus 7? Okay. And how about that? Do you see 2 different graphs here? And remember, if you click on the colored circle, it turns that function on and off. So I can turn this blue one off and the red's right underneath it. Back on, it covers the red. There's the red, cover the red. Because they are exactly the same, right? That means that's the answer. Okay, so if you have a multiple choice question with completely factored form as the choices, you can just check all of the answer choices against the original problem and see which one is the exact same. Y'all understand that? I was looking at the test results and I couldn't believe some of the ones that were like the most missed questions. There was a couple like this where they were multiple choice. And it wasn't the ones where which one of these is a factor where you kind of had to know how to factor it because it wasn't completely factored form. There was ones where it was completely factored form for the answer choices and all you had to do was check it like this. And it was one of the most missed questions on the test. Okay, don't miss those again. Okay, those should be easy to check. All right, on this one, this first one, okay, I'm going to show you something else. You could check this as well, but what if it's not one of them that's just 4 answer choices with the completely factored form? What if it's a question that says, which of the following is a factor? And you're just picking one of the factors. Okay, so let me just show you. We can do that in the calculator too. I know I showed this to you before, but obviously many people forgot because you're still missing them. So somebody read out I'm gonna, actually, you know what? I can just use it with this one. I'm just gonna erase the factored equation. I'm gonna take that out. We don't need that. Yeah, somebody read that other one to me. The first one, 33. $72T. Okay. I don't know why that one's not. Oh, I think it's because I need to use X instead of T. Okay. So in Desmos, just whatever, it doesn't matter what the variable on your paper is. Just use X so that the graph shows up. Okay. So looking at this, you can see your zeros or solutions or x-intercepts. Those are where your factors, what the point of finding the factors is to find your zeros. So here I can see I cross the x-axis here at 6, when x is 6. And then here when x is 0. So my zeros or my solutions are 0 and 6. So I could look at all the factors that are listed as choices, if this was a multi-select or a multiple choice, and I could find ones that if I solved them, do they come out to 6 or 0? T minus 6, if I solved it, and when I say solved it, I'm saying set it equal to 0 and solve. If I solved this, I would have to add the 6 over to the other side, right? So wouldn't that come out to 6? Yeah, and that's what the graph showed. The graph showed positive 6. So the factor would be the opposite sign. So negative 6, T minus 6 is a factor. Okay, now the 0 comes from the 2t, because if I have 2t equal to 0, how do I get rid of the 2? I would have to divide it, right? And what's 0 divided by anything? Still 0. Okay. So that one's not probably as intuitive for y'all because we haven't done our quadratics unit yet, and knowing that zeros are solutions, that's what the factors are finding. That's actually what's coming next. But you can look at a graph and see the zeros, and you could check your answer choices and be like, if I set all these if I set all these factors equal to 0, which one would give me this x-intercept? Okay, so that's a way you could check it too. All right, so let's look at 35. This is the last factoring one on the semester review here. And we do have 4 terms again, but is there a GCF I can take out before I try my grouping? So all those are divisible by 3 and all of them have an x. So y'all say 3x, okay? So if I divide out a 3x, that's my GCF. I'm going to put my leftovers in parentheses. What's 6 divided by 3? And what's x to the 4th divided by x? X cubed, good. Okay, and then minus, and then 3 divided by 3 is just a 1, right? And then x cubed divided by x? Good. Okay, plus, what's 42 divided by 3? And x squared divided by x? And then we have the minus, and then somebody already said it, 21 divided by 3 is 7. And the x over x reduces to an understood 1, which I don't need there. So far, so good? So I did GCF, and I've still got 4 terms. Now I'm going to do grouping with what those 4 terms left are. Okay, so I've got the first group here, and second group here. Okay, that 3x isn't going anywhere. That 3x GCF is still there. I'm going to use brackets. You can use just bigger parentheses if you want, since we've got double parentheses going on here. All right, now in green parentheses, what can be factored out of both of these? X. What's the, how many x? X to the second power could be taken out of both. And that's going to leave me with, again, if you need to actually show dividing the x squared out, that's going to leave me with 2x minus, and then what is that going to be? It's not nothing. Anything divided by itself is 1. Okay, and then in the pink, what can you factor out of both of those? 7. You're going to be left with 2. We're going to factor out a positive 7, and that's going to leave me with 2x. And then that will become a minus 1 as well, because if I'm dividing by 7, anything divided by itself is going to be that 1, right? So far, so good? Okay, close that bracket. All right, so doing my grouping, I can see that my leftovers came out the same. That's a good sign, right? That means that 2x minus 1 is a factor. And then I bring those GCFs from the grouping together. So x squared plus 7. And then that 3x did not disappear. It's still there. How do y'all feel about that? Those of you who didn't do so hot on your test, thank you. Is this making a little more sense now that we've gone over a few more? Okay. So if you, again, if you want to come to tutorials today and correct your test, look over the ones that you missed, ask questions if you need to, or just sit there and work on correcting them using your notes. You can do that. And then we will have an opportunity for a retest tomorrow in class. Anybody who wants to retake it, whether you passed or if you made 100, obviously you're not going to retake it. But if you did not make a 100 and you would like to attempt a retest, you will be able to in class tomorrow. No, the order of the factors does not matter. I could have written the x squared plus 7 first and then the 2x minus 1. The order doesn't matter because all of your factors are being multiplied. And remember, the order that we multiply in doesn't matter. Like 2 times 3 is 6 or 3 times 2, still 6.
You only gave us at 7?
No, on this retest, there's not going to be a max. You can get up to 100. So anybody, whether you passed or failed, can retest for a higher grade, even if you passed. If you don't want to, I'm not going to force you. You can, though, do test corrections and earn the little bit of points back on your test that way. Any other questions about factoring? No? Okay. All right, don't forget to use Desmos to your advantage. You get it on the entire test for this retest. You had it for this test on Tuesday, and you have it for the entire semester exam. This one?
Yeah.
Uh-huh.
Right, I think what they can be like GC.
Okay, so if there is no GCF, if we have a trinomial that doesn't have a GCF, so our A is not a 1, is that what you're asking?
It's like,
So
when
we,
can divide, like, can divide a number like.
okay, so yeah, here, let me find one. Let me go back to, there was probably one on our review. Am I overlooking our review? Oh, there it is up here, review. And if you want to, if you never looked at the review video before the test on Tuesday, that review video is still linked on our calendar. So before you come and do the retest tomorrow, that would not be a bad idea. All right, so if we had one, here, how about like this, number 3? Is this what you mean? Like there's nothing all of these can be divided by, right? Okay, so if we have one like this, okay, we have a trinomial that we're factoring, but there's no GCF. So we can jump straight into guess and check, which is how I did the one a second ago. But this time my A is not an understood 1. So when A is not 1, guess and check is a little tougher. So this is the one where I show y'all the X method. So we take A times C and put it in the top. Okay, so A is the 2, C is the 15. So 2 times 15 is 30. And then you put your B in the bottom. So my B is 13. And I ask myself, what multiplies to 30 but adds to 13? If you like making a table, you can do this making a table and just list all of your factors of 30 here. So the factors of 30 are 30 and 1, 15 and 2, 10 and 3, 6 and 5. Y'all agree? And we're looking for the ones because these are both positive. Now it has to multiply to a positive and add to a positive. Everything's got to be positive, right? So I want to know, what do these add to? This would add to 31. That would add to 17. That would add to 13. That would add to 11. What is it that I'm wanting them to add to? 13. These don't give me the right B value. So it's 10 and 3. You don't have to do it with a table, but sometimes the organization helps people. Okay, so 10 and 3. Now from here, I can do the box method or I can do the grouping method. I'll show you box. So the box method, once I get these two numbers, I am making the substitution of this B term with, instead of 13, I'm going to use 10 and 3. So remember the box method, the first term and the last term stay as is. But I make the substitution for that middle term. It becomes, instead of just being a 13x, it becomes 2, a 10x and a 3x. So far so good? Then I do GCF of every row and column. So the GCF of this row, what can I factor out of both of these? Just an X. What can I factor out of both of these? Now the columns, what can I factor out of this column? 2x. Yeah, an X can come out as well. What can I factor out of this column? And those come together to be my factors. So it's X plus 5 and 2X plus 3. And if you wanted to check that, how I showed you to check it in Desmos, plug this original in and then plug this factored form in, they should be exactly the same graph. Make sense? Okay. Uh-huh. These were special cases. The special cases I gave y'all the formulas for. Remember, if they are a difference means a subtraction of two perfect cubes, meaning two that you can take the cube root of, there was a special formula. Okay. And the formula was if you have a cubed minus b cubed, this would break down to be a minus b, and then a squared plus a times b plus b squared. Okay, and you don't have to have that memorized. That's on the formula chart. But what you have to understand is what is a and b? It's the cube root of these two numbers. So the cube root of this first number. So if I take the cube root, okay, the cube root of 8 is 2, and the cube root of x cubed would just be x. And then I say, okay, what is the cube root of the second term? The cube root of 27 is 3. Now your calculator will find the cube root of the numbers for you, like the cube root of 8 is 2 and the cube root of 27 is 3, but it won't do the x. You have to understand the cube root and the cube cancel each other to just leave you with the x. Okay, so that's your a and b. So then it's just simply plugging them in the right spot. So I've got 2x everywhere that I see a, and I've got a 3 everywhere that I see b. And then I have to remember the operations that are happening. This is being squared. These are being multiplied. This is being squared. So the 2x minus 3 stays 2x minus 3, but here, 2x squared. The 2 is squared and the x, so that becomes 4x squared. Here, 2x times 3 would be 6x, and 3 squared would be 9. And that's your answer. So those special cases are a little different. There's a special formula for them, and I give you the formula. Now that will be on the retest tomorrow, but I don't think the special cases like this will be on the semester exam since they didn't put them on the semester review. I think the ones on the semester exam are more likely to be the ones they put on the review, which would either be the grouping or GCF and trinomial, like the more basic stuff. How y'all feeling with that? A little better? A lot better? Good. Okay, come to tutorials. I have tutorials today. I'll open up your test for you to make corrections, and then you can come ready to retest tomorrow and get that grade up. Okay, and we'll finish. Y'all continue working on your semester review, some of the others that we didn't get to, and we'll go over, if you are not doing a retest tomorrow, we can go over more questions. If we don't end up having time, if everybody's retesting still, that's okay. I will post the videos of me going over the rest of the semester exam. So y'all just keep working through that semester exam through the weekend, all the way up until your test. First period is on Monday. Okay. I have tutorials today and tomorrow you can come to for help.